Hi, my name is Debanjan. I am a PMRF research scholar in the Department of Mechanical Engineering at IIT Kharagpur. I will be acting as an external TA for the course of Mathematical Modeling of Manufacturing Processes. So, during the course, we will be having some problem solving sessions in the weekend. So, I hope you'll go through all the lecture videos of the course during the week, and we'll having some interaction session, some live session from the content of those courses. So let me go through this assignment 0. This is a dry run. Now the question 1 talks about fluid flow is associated with which one of the following manufacturing processes? Is it fusion welding? Is it rolling? Is it powder metallurgy, or is it metal cutting? I know you all know the answer of this question. The answer, of course, will be the fusion welding. So if you see the fusion welding, you will have a filler material. You will have a torch from where you generate the heat flux. So because of the generation of heat flux and the melting of filler material over the base metal, there will be all over a melting of the parent material, and eventually a solidification process happens. So fusion welding basically depends upon melting and solidification process. Now if you see rolling process, so you'll have some two rollers like this. These are rollers which are of same radius, and you'll have a sheet which you insert through the rollers, and where the roller gives apply some pressure which is called as roll pressure, and due to deformation process there will be a reduction in height, where hi is initial height and hf is final height, right? Now in case of powder metallurgy, you can mix two powders properly, then you compact the powders through applying some pressure. So say here you have a die and you mix up the powders here, and you apply some pressure through punch, and you can create a green compact like this. So after preparing this green compact, you raise the temperature of that green compact and apply some pressure during sintering. This is how the powder metallurgical process happens, right? Now in metal cutting, you will have some tool, you will have workpiece, and because of the shear deformation in this zone, the workpiece will cut away in the form of chips. So this is basically a metal removal process. Now question 2 talks about asked about electromagnetic forces associated with which one of the following manufacturing processes. I'm pretty sure you know the answer. So the answer will be induction welding. I hope you all know this casting and solidification, metal cutting, of course, will not be associated with electromagnetic force. For laser welding, this is associated with uh, optical source of laser, where you consent where you generate a heat over the base metal, and some intense heating happens over a small amount of area, for which some melting and vaporization uh, of this base metal or parent metal happens, and it eventually gets solidified. So yes, induction welding is associated with electromagnetic force. So in I hope you all know how induction heating happens. So say these are your two metals, and you need to join these two metals, and what you can do is like you can have some conductor kind of thing through which the electricity can pass, and you will have some induction coil through this. So due to application of current will pass through this conductor, and some AD current will generate, right? So due to generation of AD current, and depending upon the electrical resistance of the material, the sheet gets heated up, right? So when you applying some temperature, you apply also some pressure to this roller, and you generate the bonding. Now question 3 asks about thermomechanical processing and recrystallization are mainly associated with which process? Is it casting, metal forming, fusion welding, powder metallurgy? This is also a very basic question. For casting and fusion welding, these are associated with melting and solidification, right? So say this is your liquid alloy. This is your liquid alloy. When you solidify the metal, some nucleation starts to happen. So just a minute. Yeah. So some nucleation starts to happen, and with time this grows up like this, and eventually they form some grain boundaries, right? So in melting and solidification, there is no point of recrystallization as such. Recrystallization happens when you do some metal forming, some hot metal forming, like hot rolling, like friction stir technique. So say for friction stir technique, you have a tool and you have some workpiece. So I am showing you the lab configuration here, and you can have some pin also. So you rotate the tool and you apply plunge here. So due to mechanical deformation between tool and the due to friction between the tool and the workpiece, the heat will generate, and also some plastic deformation happens at the interface. So basically what happens in the microstructure, like if we doing some cold working at room temperature. Just a minute, huh? Yeah. So if you are doing some cold working at some room temperature and you deforming the material, so initially your grains are like this, and when you are deforming the material at room temperature, they get flattened, right? They get flattened like this. So there will be huge amount of strain hardening. Yes, your hardness will shoot up, but you compromise the ductility here, right? So and also your dislocation density will shoot up. I'm not going into detail now, but if you're applying some temperature, See, during the deformation process itself. So during the cold working, your dislocation gets like in haphazard way. It can piled up somewhere like this. Now when you apply some temperature, when you apply some temperature, then your dislocation line gets arranged like this. So this is called recovery. It's getting arranged in a in an array. So you apply more temperature, then in your microstructure some new strain free crystal structure generates. These are fine microstructure like this, and and with time and temperature, eventually all the microstructure gets recrystallized, right? So these microstructures are strain free. It's all strain free new microstructure. Sorry, strain free new microstructure. So yeah so yeah the question was thermomechanical processing and recrystallization are mainly associated with metal forming. Now in question 4 it asks about to estimate the temperature distribution, which of the following equation is solved? Joule heating, Navier-Stokes equation, heat conduction, Gauss equation of magnetic flux. Yeah, of course it will be heat conduction. So I have given you the equation. I know, I hope this equation is very familiar with you. So these are the thermal conductivities at x, y and z direction, and this is your temperature gradient. This is your generation of heat. Sorry. And this is net heat leaving the surface. So this term is heat accumulation, and this is heat leaving. So basically, if this is your say control volume, and you have some area, so what will be the heat accumulation here? Say your heat flux is Q, so it will be surface integral Q dot N ds, right? I'm not going into detail, of course. This equation can be written as something like this. Let's leave it here and trust me that this equation is true. So heat conduction equation is used to estimate the temperature distribution. Now question 5 is about solidification process is associated with metal cutting or metal forming, solid state welding or fusion welding. So of course this is fusion welding. So in fusion welding you basically there will be a weld pool, which will be a melt weld pool. this will be a melt weld pool, and this will be of highest temperature, which is the melting temperature of the material, right? So, and the subsidiary portions also heated up. Here also some rise in temperature will happen, correct? So when you solidify the things, of course there will be a grain distribution. So the change in temperature starts from the coolest zone of this thing. So here it starts, and there will be a columnar grains because of this temperature gradient, and depending on temperature gradient there will be fine and coarse microstructure around the weld pool. So yes, solidification process is associated with fusion welding. Now question 6 asks about mass addition to the solution domain is associated with which of the following process: sheet metal forming, or metal cutting, or metal printing, or autogeneous arc welding. So I hope these also is a very simple question. So this is the correct answer is metal printing process. So in metal printing, you will have some substrate material. Maybe you can have some laser source, say, and I am talking about say selective laser melting, and you distribute the powder here, and because of this heat flux, intense heat generation happens, and it melts up here, and it is a moving heat source. So it's at instant of time it heats up and then gets solid, then melts and then solidify. So with time and with heat source travels during this direction, at this direction, deposition thickness a deposition happens over the substrate, which will have a thickness. So say this is called deposition thickness. And after the first layer you deposit, you will again distribute the powder and again do the same thing, and it will have a layer by layer process, right? So there will be huge amount of residual stress here because of this temperature gradient, and also there may happen some distortion of this substrate material as well, at the deposition due to the temperature gradient. So these are more detailed things leave it here. So for mass addition, yes, metal printing is the technique where the mass addition happens. Yeah. So question 8 asks about anisotropic plastic deformation is associated with mainly friction stir welding process, heat treatment process, or sheet metal forming or bulk metal forming. Yes, of course this will be a sheet metal forming process. So when you apply some roll pressure in the sheet material, there will be a reduction in height. So if you think it in 3D view, right? So of course there will be a strain in longitudinal direction, and there will be a strain in transverse direction, say HT and HL, and final HLI and HDI. Here the final is HLF and HDF. So what will be your longitudinal strain? Hmm? Log HLF by HLI, right? And what will be your transverse strain? Log HDF by HDI, right? So these true strain will be different in different directions. So if you taste some sample, some rolled sample, and you apply some uniaxial tensile test, say at 90-degree direction, uh, this is one case one. Now you cut the sample at 45 degree and apply some uniaxial tension. So there will be basically, I want to say that the strains will be different at different direction. So if you cut the sample at 90-degree, it will have different strain. You cut the sample, if you cut the sample at 45-degree, it will have different property. So yes, because of the rolling pressure and deformation process, sheet metal forming process is associated with mostly anisotropic plastic deformation. Question 9 asks about, to obtain good surface finish, which one of the following process is most suitable? Conventional machining, lapping and honing, grinding, or electrochemical? I'm pretty sure you also know this answer also. So this will be a electrochemical machining process, because this conventional machining process, lapping, honing, grinding, all are kind of abrasive kind of thing. So yes, basically the electrochemical machining process is atomic dissolution of the anode, right? So you'll have the cathode, which is your tool, and your anode is your workpiece. So depending on your electrolyte electrode combination, the anode will get dissolved through some atomic dissolution, and very minute machining happens. So yes, for good surface finish, electrochemical machining process is most suitable. Now, in question 10, it has asked about to correlate the energy source used for different manufacturing processes. So here optical source will be associated with laser beam machining, electrical source is associated with arc welding, electrolysis or chemical process is associated with electrochemical, and mechanical source is extrusion process. I am pretty sure you all know the basic mechanisms of the processes, and yeah, this is a very simple question. So yes, that's it from my side. Have a good day. Thank you.